Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques video series. This is episode 17, and today we are going to be talking about the master model technique. And over the course of this next 30 minutes or so, I'll be introducing you to the master model technique and what it is and how it works, and what are some of the best practices for using this technique. I'll also cover 4 different methods for using master model in SolidWorks, and then it's quite likely that there's too much information here for one episode, so I'm going to probably spill over into our next episode, show some practical uses of it in SolidWorks. For most of this episode, we will be just talking about what it is, why it is, introducing you to the different types that you can use to put master model into your workflow. So it'll mostly be slides. It won't be showing SolidWorks, although I'll try to break away once or twice to show a practical example. Most of that will come in the second episode, and we'll probably get more into SolidWorks as I talk more about how to overcome problems or issues that might arise in using master or base derived parts and how to correct that. So this is really an introduction, and if you well know how to use master model in SolidWorks, you might want to move to the next episode where I talk more in detail about how to overcome problems. But for now, I'm just going to start talking a bit about what this is, as if you were a new timer to this subject. So master model technique, what is it? Why is it? Why do we have it? Well, it was first coined by PTC, Pro Engineer, in the 90s as a way to parametrically drive different parts from a master or base part. So the idea is that you have one master part that then drives 2 or more derived parts. And this can be very useful, especially for consumer product design. And I mentioned consumer product design because consumer product design in many cases is made up of advanced shapes. That is, they aren't really prismatic and they aren't really easy to associate to one another in an assembly or through other methods. You really the most effective way is to create a primary shape of the product and then divide it up. It has to be divided up in a lot of cases because you really can't manufacture a enclosed shell on its own. So manufacturing really dictates that we need to build derived parts of plastic parts that then fit together to enclose a product, an electronic product or mechanical product. So this is the reason that it exists. The master-slave relationship is one where the base part or the master drives all the derived parts. There isn't a two-way symbiotic relationship, and this is on purpose because you want the main shape to really dictate what the derived parts turn out to be, and if any changes are made in the master, they trickle through to the derived parts. It's also, by the way, not just for consumer product design. It's a good technique for machine design and other industries also. I find it particularly good for creating motion mechanisms where you can create your parts that will work in motion, but then you separate the motion using master model as you assemble them back into your assembly. I'll talk more about that in a few slides down. So how does it work? SolidWorks built into it has a few different techniques for doing this, but basically you create a start part or a master part that contains all the geometry that's necessary to define the exterior shape and even interior boss points and whatnot if we're talking about consumer product design. And then at the end of the tree from the master model part, you can derive out individual parts that then share this geometry and become the first feature in the derived part, where then you can add further detail. And then after the parts are completely detailed, they are assembled back into a main assembly that then becomes the product. I talked about the base part is the master, usually referred to as the master model. The slave part is usually referred to as the derived part. And if you look at a master model relationship with the derived part, you'll see in the derived part you have the first feature always being, well, it doesn't have to be the first feature, but usually the first feature is the stock feature, and this stock feature is the actual geometry from the master. So everything you build past this point in the tree of the derived part is added on to that geometry. Now the beauty of this is that you can create your master and then drive geometry to two or more parts, but then you can also change the master to reflect changes in the product design with very little work. You don't have to, obviously, if you were to create all the derived parts or the parts or components separately, you'd have to update all those parts individually. This is a way to use history-based parametrics to drive features between parts, and that's essentially what it is. The general workflow is basically you create a master with multi-body parts, and in SolidWorks, unlike Creo Pro-E, you can do that now since they have allowed solids to be done since it was created in the 90s, but generally SolidWorks users will use multi-bodies to create what will be the individual components in the master model. And then using the Save Bodies feature, you can derive out those multi-bodies into their various components. So this slide is a really important one to keep in mind and to remind yourself constantly what's the best practice for using the master model. And I call it the master model golden rule. It's really when you ask yourself, what features do you put into a master model? And it's pretty simple. And it's basically you put geometry into the master that is shared by two or more parts, not one part, but two or more derived parts in your product assembly. Conversely, you don't put geometry into your master model that's only going to be in a single part. It makes sense not to do that, right? Why would you do that when you have a single part? You you make that its own component and add all its own geometry to that single part. So I hope that makes sense. And I see when people get into trouble using master model, they're probably breaking this rule. And that's why I think it's really important to remind ourselves that this is really smart thinking, to always remind yourself of this master model golden rule. It keeps you out of trouble, basically, along with other best practices that I'll share in a moment. So following on to that, what are the rules of thumb for best practices? Well, first, not surprisingly, follow the golden rule. I mean, that's really paramount, to follow that first. And then ask yourself, if you're going to break that golden rule, why are you doing it? And you might find that there are some legitimate reasons for breaking the golden rule. And we'll talk a little bit more about that too. Also for me, and this is just my advice, that if the part is simple, let's say it's a prismatic part and it can be easily created from a few features, it doesn't really necessarily need to be in the master model. You can drive it dimensionally very easily from just editing the part in the assembly, and you don't have to do that in the master. Also, I often do bring in stock parts to the master to use as reference, but you should never rederive them out. That's really not necessary, and it adds to the burden of managing the whole process. So it is important to bring in stock parts like screws and components, electrical components, that you can design your master to, and especially if two or more parts are going to reference that. But never derive them out again. Use the original component in your assembly. I think that pretty much makes sense. And we'll show you, if you do use stock parts, you want to probably delete their bodies towards the end or before you do a save bodies, just so everyone's clear that those are not included as derived parts. I see this a lot, and so we're back at the golden rule. I see the golden rule breaking a lot, and it's usually when you have teams of designers creating multiple master models, and you create master models of the master model. SolidWorks allows this. You can derive as many parts from another part, and you can create a pretty complex chain of dependencies. But it comes with a warning. When you start to do that, you're increasing the chances of failure, because there is so much dependency that in times where products are changing, it can be very hard to repair when you have multiple chains of master models. So I understand the pressure that there might be to do this, especially if you have a large team of designers and you want to divide up the work. But I would suggest that instead of creating a master of a master, that you break it apart into parallel masters that don't have any association with each other. And in many cases you can do this, where you have one part of the product that is driven by a master, and then those derived components are created and put into a subassembly and then the main assembly. And you can do likewise with multiple other parts of the product that are driven by their own masters. When it simply cannot be done that way, and that is that you have various masters in your design that all have to share some key start component geometry, then what I would suggest is to create a master drive sketch that then can be created, could be used by various masters. And what I mean by this is that the master drive sketch doesn't create or contain any solid or surface geometry usually, but it's just made up of some simple sketches and planes that define the parameters of the product. Maybe it's just the front profile and the side profile of the design. And it's very simple, very easy to understand. The sketches are all named for what they are, and it can be referred back to when the overall design changes in any way or even significantly. Then the master drive sketch is very simple and it can propagate down into the masters, but usually not any complex surfacing or solid modeling in the master drive sketch. And when I say master drive sketch, it's really just a part. It's just a part with sketches in it. So that needs to be understood. But what I see a lot is, and we've even done this at Spanner and learned from it, is that if you create a drive sketch that gets too large and complex, and I blurred this image out of an actual product that we worked on that had maybe 100 different sketch and plane features in it, it gets unwieldy. It gets very hard to manage, especially because sketches are only two-dimensional, and you usually need to have two positions of that sketch to define the 3D, so a front and a side view, for instance. And it's hard to navigate through sketches. Sketches are limited in the information that they can give you. They're also very hard to colorize, and we've tried to do that too, where we've colorized the sketches, but then it's hard to manage that. So just my warning to you is, if you're going to use a drive sketch, keep it really simple. Be very judicious about what you put into it. And I would say a drive sketch that is larger than maybe 20 or 30 sketch and plane features is probably too big. And again, go back to the golden rule of master model. Ask yourself, does this really need to be done this way? Or can the master or masters really be adhered to derive two or more references for derived parts? So if you are going to do a master sketch, make sure that you actually name the sketches and put them into logical orders. Make them easy to get back to, because when you use a master sketch and it's referred to by many designers, it needs to be very easily understood. So kind of put yourself in the shoes of your colleagues to know that it's got to be just dead simple to understand. Another warning about the drive sketch, and this is really a warning that if you're going to use a drive sketch instead of master model, that is, let's say you have a drive sketch that is driving all of the derived parts, and you make it large, let's say we put 100 sketches in it, what you're going to be doing to yourself when you get to the assembly is not going to be something that you're really going to like. That is, you have to remember that if you have 100 sketches in each of your derived parts, that means it's 100 times whatever derived parts there are as sketch features in your assembly. So if you've done this and used the drive sketch instead of a master, and you put a lot of features in that drive sketch, it's going to be really hard to manage in your assembly. I think you just have to get to this point and see what this is like, but basically trying to do a search of the feature manager in an assembly can take minutes when you have this many features just propagating through to the assembly. That's a word of warning about just using a drive sketch. Of course, also, and I think many consumer product designers know this, that even though SolidWorks was built to do in-context assembly modeling, for consumer product design, especially when there is lots of surfacing involved, I would not recommend it. The reason being that, and this is another method for doing an alternative method to master model. If you were to do this, where you were to build up a shape like what I'd shown earlier in context assembly, that is, you create a component, a master component in the assembly, and then have all the or drive sketch, and you have all of the components in that assembly constantly referencing it, you're going to find that your performance is going to be almost unbearable, because any change you make in any one of those components, not just the master component, means a rebuild for all of them. So doing any kind of significant change to the product in its early phases is just going to be very hard from a performance standpoint and a management standpoint to do it in SolidWorks. Now, for simple machine design, this is perfectly acceptable, because simple machine design is not a performance burden like consumer product design, especially with surfacing, that and it can handle this. I'm really speaking to more consumer product design, that this is really not a very attractive alternative to master model. And it's the reason that master model exists, actually. So the reason that master model is a better technique over this is that the master model technique isolates the rebuild from the derived components. And I'll talk more about that. But basically, when you have a large team working, or just yourself working on derived parts, you're just editing and changing that derived part and its features. If you need to change the base, then you go to the base and you update. But many other subsequent features in that derived part can be done in isolation of the rebuild of the master. So that's really one of the keys that makes master modeling work so well. So if you are a team of designers, or even yourself as the author of both the master and derived parts, it's a really good idea that in every version of SolidWorks, or put this into your copy options wizard, to set your external references from change only to prompt or none. Now, I say this because the default with a default install of SolidWorks is change only. And the reason that I warn you about this is that this is a dangerous default setting. And the reason is that if you are a team of designers and you have changes being made by one person in the master, it's really not known those changes that will occur in the other team members that are working on the derives. Because if it's change only, it means that they load their derived part, it'll go and load into memory the master and make changes. And it very well could be that the author of the master is making changes but is not yet ready to publish those changes. So that's what this setting is all about. And what I would recommend is that you set it to prompt or none. I set it to prompt. So every time I open the derived part, it asks me, do you want to open the master? And I usually say no. So it's really imperative, and all of my colleagues at Spanner, we set this setting to be this because of this potential issue. So I would highly recommend that it's one of the first things you do if you're doing master models, to make sure that this setting is on prompt or none. Now, moving on to the mechanics of master model and how it's done in SolidWorks. There's 4 different ways that I know of to employ master model in your product design. If there's actually more than this, I'd really like to know, and if you want to email me with the information I'm showing in every episode, let me know. But these are the 4 that I know of, and they were brought into SolidWorks in various points in their history, and each one is a different way to add different capabilities depending on your master model workflow. So the first one that I know of is what I call the insert part push, and this is done using the right mouse button on a body in your solid bodies folder. Now, all of these assume that, let's say we've already created our master model in the way that I've described, where you've created a master with all of the geometry that is going to be used and shared by 2 or more derived parts. So we're going to start from that premise. And then you have different ways of doing that. So this insert part push, let me show that just really briefly here in a SolidWorks part. So here we have a SolidWorks part. It's the sound doc I created about a decade ago for illustrating master model technique. And what we've done here is we've created a base part or master model that is designed to reflect the various different components that will make up this product. So let's say, for instance, if we're talking about the first method, insert part push, you can go to any of the solid bodies in the solid bodies folder, right click, and then use the insert into new part choice. Now, of course, you have to give it a file name, so we're going to give it a file name and call it something like front housing insert push, just so we're clear about how this was created. And when you click save and then confirm, you should get a derived part of just that component or body. So that's the first way of creating this master model technique, or first method. So moving on, the next method would be much like the first one, insert part. But in this method, what you're doing is you're actually inserting the entire base part into the derived part. And then it's a matter of just removing any non-related bodies or references for that particular component that you're deriving. So if we go back to our master here, this second method would be basically you create a brand new empty part. And here I'm just going to use our spanner templates and create an empty part called part 2. And then at this point we insert the master into this. So I'm going to pick my master here, and I have a choice here of what I can bring in. I can bring in just the solid body like I did before, or I have the choice to bring in many more type of entities into it. For right now, just bring in planes, axes, and solids. And you also get the choice to locate it once you bring it in. So let me just accept, and we're just not going to locate it. So you can see here I've brought in the complete master and its planes. And at this point, usually when users use this method, what they'll do is they'll immediately do a delete or keep bodies feature to just isolate the one body and use it forward in this derived part. Now you can do that by just clicking here and hitting your delete key on your keyboard, and you can see that you now get a choice to keep or delete bodies. Before we could only just delete everything else and keep the one. Now we can just say we want this particular body to be kept and everything else deleted. So now we essentially have what we had before with the push method, but we can also bring in other entities with it, which is an advantage to that. So let's move on in our methodology of how we create our master. So the third method is save bodies, and this is the one personally I use the most, and I use it the most because it is the most reliable and most robust of the three. And I'm going to talk more about the advantages and disadvantages of all of these. But save bodies is the one that we at Spanner use the most. And let me go back to my SolidWorks part here. The save bodies feature differs from the other two insert methods in that it's its own feature that lives inside the master. And so to get to that, you go to Features, or Insert Features, Save Bodies. And with that, it'll identify all the bodies that can be saved within the within this this master part. If you look at my solid bodies folder, I've carefully named all of the parts as if they were the component names that are going to be derived out. And then additionally, I've hidden some bodies. These thickens that are part of the overmolds of the handle are hidden. And when you invoke the Save Bodies feature, they will not be included into this list. That's a by design thing to make managing part files with lots of multi-bodies easier. So one of the helpers we have is the ability to click on this floppy disk icon and automatically name all of the bodies as if they to name the file names with their body names. And additionally, we can consume these. I don't use that usually for save bodies, but for split. And then also propagate visual properties. Again, I don't use that because I want each of the components to have their own visual properties. You can also create an assembly of all of them to automatically regather all the derived parts back into a main assembly. We're going to call that sound dock main assembly. And with that and these names, then we're ready to just derive these out. You can unselect ones that you don't want in this list, or you can just include the ones by default. And then we're going to go ahead and click on Save Bodies. And as we do this, it's going to be taking each of those solid bodies and deriving it out to its own part file. And once you have that done, you can notice that you now have a new assembly created of all of those derived parts in place. And you notice that they are not floated, but they're in place. If you want to float them and then remove them, you can do that. Moving to our last method for a master model would be to use the split feature. And this I find useful if the actual part you have is going to be an actual component, but you need to split maybe one part of it out as a derived part. So let me go to an example model and show this. And we have this upper housing that we have a label that's going to go in this area, and we need to derive this further just to get the label and keep it associative to the top housing. So if we do the insert feature split and then use this as the trim tool and select this as our body, we can cut it, and then we can just derive out the label itself. So I'm going to go ahead and assign this as a label for upper housing. And again, also we can consume it, meaning that with the completion of the split feature, and let's go ahead and complete that, we have the, let's hide the quilt too. We actually have just the remaining part that we'll be using as a component, but if you look carefully in the tree, we've split out the label and it's its own part. So this is where if you want to use the part as its component but need to split out further, this would be a good case of that. I would say if it's more than one thing you want to split out, you might need to reconsider the golden rule of master model and maybe do it as a save bodies. So that is, but in this case, I think it's a good use of the split feature for master modeling. It looks like I've run out of time for this episode, so I'm going to continue to talk about master model in our next episode. And in that episode, I'll talk more about the advantages and disadvantages of these 4 methods I just showed, as well as talk about how to overcome some issues that you might have when using saved bodies, namely the fail to save document and the naming issues that sometimes arises. And I'll give you some tips of how to overcome those. So I'll see you in the next episode.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.